In the vast expanse of our solar system, beyond the familiar 8 planets, lies Pluto. This distant world was discovered in 1930 by astronomer Clyde Tombaugh. Its discovery caused a sensation. Pluto was hailed as the 9th planet, a distant and mysterious addition to our celestial neighborhood. It quickly captured the imagination of the public, becoming a symbol of the unknown reaches of space. For decades, Pluto held its place as the 9th planet. Schoolchildren memorized its name alongside its planetary siblings. Scientists studied its faint light, eager to unlock its secrets. However, as our understanding of the universe grew, so too did our knowledge of Pluto. New and more powerful telescopes allowed astronomers to probe the outer solar system with greater clarity. They discovered a region beyond Neptune populated by icy bodies. This region, known as the Kuiper Belt, would hold the key to Pluto's fate. Pluto, it turned out, was not alone in its corner of the solar system. It was just one of many icy objects inhabiting the Kuiper Belt. This realization led to a debate among astronomers. What exactly defines a planet? This debate would culminate in a momentous decision that would reshape our understanding of the solar system. In 2006, the International Astronomical Union, or IAU, made a historic decision. They reclassified Pluto as a dwarf planet. This decision was met with both support and controversy. Some people felt that Pluto had been demoted, stripped of its planetary status. Others embraced the change, arguing that it reflected a more accurate understanding of the solar system. The IAU's decision was based on a new, more precise definition of a planet. According to the IAU, a celestial body must meet 3 criteria to be considered a planet. First, it must orbit the Sun. Second, it must be massive enough for its gravity to pull it into a spherical shape. Third, and most importantly, it must have cleared its neighborhood of other objects. Pluto met the first 2 criteria but stumbled on the third. Its orbit overlapped with the orbits of other Kuiper Belt objects. It had not cleared its neighborhood in the way that true planets do. Therefore, the IAU reclassified it as a dwarf planet, a new category created to accommodate objects like Pluto. Despite the reclassification, the scientific community's fascination with Pluto only intensified. The New Horizons mission, launched in 2006, was already on its way to Pluto. This groundbreaking mission would soon provide an unprecedented glimpse into the distant world and its companions. The New Horizons spacecraft made history on July 14, 2015, when it flew past Pluto. It was the first spacecraft to ever visit this distant world. New Horizons captured stunning images and collected a wealth of data that revolutionized our understanding of Pluto and its moons. The images beamed back from New Horizons revealed a world far more complex and dynamic than anyone had imagined. Pluto's surface was a tapestry of different terrains. Vast plains of nitrogen ice stretched across its equator. Towering mountains composed of water ice soared above the frozen landscape. Craters, evidence of a long history of impacts, dotted the surface. The mission also revealed that Pluto has a surprisingly complex atmosphere. It is composed primarily of nitrogen, with traces of methane and carbon monoxide. The atmosphere is thin, but extends far above the surface. Scientists were amazed to discover that Pluto's atmosphere even has layers, much like Earth's atmosphere. One of the most significant discoveries made by New Horizons was the presence of a possible subsurface ocean on Pluto. Data from the spacecraft suggested that beneath the icy shell of Pluto lies a hidden ocean of liquid water. This discovery sparked intense excitement among scientists as it raised the possibility that Pluto could harbor some form of life. New Horizons also provided stunning views of Charon, Pluto's largest moon. Charon is so large that it is often considered a binary system with Pluto. The 2 bodies orbit a common center of gravity. New Horizons revealed that Charon also has a surprisingly diverse surface with canyons, mountains, and vast plains. The New Horizons mission provided a tantalizing glimpse into the Pluto system, but it also left us with many unanswered questions. What is the composition of Pluto's subsurface ocean? How did Pluto's complex surface features form? What is the history of Charon and Pluto's other moons? These are just a few of the mysteries that scientists are eager to unravel. To answer these questions, scientists are already planning future missions to Pluto. One such mission is Persephone, a proposed orbiter that would conduct a detailed study of Pluto and its moons. Persephone would be equipped with a suite of instruments that would allow it to map the surface of Pluto and Charon in high resolution, study their atmospheres and magnetic fields, and search for evidence of subsurface oceans. If funded and approved, Persephone could launch as early as 2031. The mission would last for over 3 decades, providing a wealth of data that would transform our understanding of Pluto and the Kuiper Belt. Pluto, once considered the 9th planet, may no longer hold that title, but it remains an object of fascination and intense scientific study. From its icy plains and towering mountains to its possible subsurface ocean and complex atmosphere, Pluto is a world full of surprises. As we continue to explore the outer reaches of our solar system, Pluto will undoubtedly continue to captivate our imaginations and challenge our understanding of the universe.